Hello, Shubham.
Hi, Dheeraj. How's it going? Can you hear me?
Yes, we can hear you.
I guess we wait for a couple of minutes before others come in.
Hi, good morning.
Hey, KB, how are you doing today?
I'm fine. And
Nice. I'm just setting up a few things while others are joining in.
okay.
Just gonna text in the WhatsApp group so others can also join. Give me a minute. Let me quickly share the link to the learners as well, and then we can get started. Hey, Swapnil,
Hi Shubham, how you doing?
I'm good. How are you?
Yeah, I'm doing good.
Well, cool. I think we can get started now. I've already sent the message in the group, so people should be joining in soon. The session is already in, the call is being recorded, so that is good. Before we get started, guys, I would like this session to be as engaging as possible. Welcome to Coding It Live, a policy engine for Kubernetes. Um, so if you have any questions, just feel free to ask while we are doing it. There would be a bit of a theory first, and I'll talk about what are we going to do, and then we take it from there. So let me share my screen. Here it is. Allow. I would rather share the entire screen and then share. Okay. So as I said, I would like the session to be really, a two-way interaction if possible. Let's start with a scenario, and then I'll tell you what are we going to be building today. So you might have been using Kubernetes because for this call, it is important to know Kubernetes. It is important to know how do you interact with a cluster. You need to know these basics. It's not a really friendly for people who don't know Kubernetes. That would be a bit of an issue. But you're expected to know Kubernetes because you'll be building something for Kubernetes. You need to know how does it work with the RBAC, which is the role-based access control. You also need to know how to work with authentication with an API server, which you can do with your kubeconfig file that I'll be using. Okay. So let me ask you this question here, and I'm sure some of you would have this answer. Let's say you work with a company and you have a requirement. Oh, that's a bit. Okay. So you have a requirement that there is this developer. Okay. There's this developer and they want to run a pod on Kubernetes. It's a fairly straightforward thing. They want to have a pod on Kubernetes, but and they use a YAML manifest for that, right? They could use a UI, they could use a CLI, it doesn't matter. All they are giving you is a YAML manifest, and that is where your pod will be created. However, I have a few questions that I want to ask to you guys. How would you limit or how would you validate? For example, this guy is working for a team in the company called Order Control. Let's say he works for a company or he works in a team called Order Control. And you, as an administrator of your Kubernetes platform, you need to know what workloads are related to what team in this company, because there could be many teams available, and you want to make sure you can filter out on how much capacity or how many pods are running for a certain team. So you want the developers to have some labels. Okay, let's say you work for Acme. You work for a company called Acme, and you want certain labels to be present on your pods, which is acme.io/team. And this is where they should have given their order control. I don't have a PDF. I didn't bother planning one because I like to draw stuff around. That makes more sense to me, and I think to everyone else, rather than me reading from a boring PDF. Okay, so you want some labels to be present. However, this guy just gave you a pod manifest that does not have those labels set. How will you enforce this? What options would you do? Like the first thing you could do is you see that the pod got created, you manually check the pod and you say, this does not have a label. Maybe Swapnil forgot to put some labels on the pods. Then, as an administrator, I would probably go to his desk and tell him, ping, ping, Swapnil, can you delete your pod and have it with the right label? Of course, it's doable if you have one team or a handful of developers. However, when you have hundreds of teams that are each like 10 or 50 people working in a team, you have so many users of your platform. It is not humanly possible to go to everyone and say, please have this label. I'm going to delete your pod because you did not put one. So does anyone know how would you enforce this thing? How would you say, if there's no label with your team name, the pod will not be, admitted on the cluster? How would you do that? Any ideas? What we're looking for is validation. So how would you validate such requests?
Maybe create a policy around it so that, when a
Mhm.
pod is created, which needs to have the label, or it won't be, if the policy doesn't surpass, the pod won't be created.
But how would you write the policies? What I'm saying, do you use a tool for that, or what would be your, what would be your first thing? Maybe Kumail also, I think he has joined, so he also would probably have an answer. Kumail, what we want to do is we want to limit some people to be able to create some pods based on if they are missing any label. So how would you probably do that? This is a question to everyone.
Can you pardon?
So the question is, there's this team of developers, and they are submitting pods left and right to your Kubernetes cluster. Okay. You want to stop them creating a pod or allow them to create a pod if they are having or missing some label. For example, let's say you work for a company called Acme, and this guy is a part of team called order control. You want to limit them to create the pod if they don't have a label called acme.io/team colon the name of the team which they are part of. So you want to validate the request before it gets to the HCD and the pod actually shows up. How would you try to come up with a solution for this?
First of all, I would be using labels and selectors,
Hmm.
and based on that, I will be putting an RBAC rule so
Hmm.
that I will be creating a group of developers, and then I'll be trying to make it like if they are not selecting any labels, which is this Acme, so they won't be able to create the pod based on the RBAC. And if they are, then they will be getting the kind of rule. Then they are getting in the particular namespace. They are able to create some pod and all. But mostly we will be using label selector with RBAC.
Right. So you would be using a label and selector, that's definitely for sure. However, RBAC is there to say if you can do a certain action on a namespace or not. For example, there are 6 verbs that you know. You can update a pod, you can delete the pod, you
Yeah,
can create the pod. That's where they are limited to. They can say whether it's a binary, right? You can say whether you can create a pod or you cannot create a pod. You can also use quotas, that how many pods can you create in total. But that is where RBAC would actually fail to work, because RBAC is like, I can allow or deny. I don't have any view of what object are you creating. I don't validate on that object. I only validate on your permission. So that's where RBAC would fail. So the thing is, what you can use for such easy tasks is a tool called Kyverno. You might have heard about, some of you might have used it, right? So with Kyverno, it is a tool that can help you validate these requests before you can admit them to the cluster, or you can not do that. Now, what is it that Kyverno does in the background is what the agenda for our session today. We would be actually coding or building our own little Kyverno that we can extend to fill the gaps that Kyverno actually has. And then you can see it's going to open a lot of options for you, what you can do when you work in the Kubernetes world. For example, if I ask you guys again, how will I limit someone to create n number of pods? How would you do that?
policy
I
as
mean,
code.
you would be using something like, again, here you would use quotas, right? In Kubernetes for your
Yeah,
namespaces. You could say, my namespace has only a quota of 10 pods maximum. But imagine, Kumail, that you are a company that provides that provides some resources to some customers. Some of them would be premium, some of them would be standard tier. So how would you limit someone to create n pods in last 5 minutes? That is the question. I'm not saying how would you limit them entirely. I'm saying how would you limit them that they can only create, let's say, 10 VMs in last 5 minutes? How can they create 20 persistent volume claims in last 1 hour? So these things, again, you can do the limiting on how much can they do using quotas. that works right out of the box. But you have to think beyond what quotas can do for you. In this case, when you want to do some stateful decisions, even if you could have used Kyverno here, Kyverno fails short as a policy engine because Kyverno is also stateless. It only looks on your current request. It doesn't look on the request that you have done previously. It doesn't remember what happened in the past. It cannot go to Prometheus. It cannot query, tell me how much this user has created, how many pods in this namespace. That doesn't do that. It is completely stateless. So that is what we're going to learn in this call. This is going to be the agenda. And I plan many such calls where today we will be validating something. In the next calls, we will learn how to change the request that the user has given. You know, when you create a pod, it gets some additional fields added. When you do kubectl get pod -o YAML, it has an additional field called a service account. You did not give this in your pod YAML. It has an additional field called maybe, some other fields are added to the pod. So who does that? How does that happen? Is it authentication? Is it authorization? Or is it something else that's working in the background that we never care about? Because tools like Kyverno did it for us. But today, we're going to build one, and that is called an admission controller. That is the agenda that we'll be working on. So the request flow actually goes like this. The first thing that you are here is the user. The user goes on and he passes this wall called authentication. You have to be authenticated by Kubernetes. That yes, this is a valid user. You can have different backends for authentication. Maybe you can use OIDC. Maybe you can use a simple, HA proxy. No, it's not HA proxy, but basic authentication. Different ways are there. And once you are authenticated, the next step that your request passes is the RBAC. That maybe you are a valid user, but are you allowed to do something on this or not? And this is also a binary thing. It just says yes or no. It doesn't say, based on the request, no. It just says something on an object level that can you create a pod? Can you delete a secret? Things like that. It doesn't look on the spec of your of the object that you're sending. The thing that does that is this bit. This is what we're going to be learning. And these are called the admission controllers. Admission controllers are a piece of software that are running in your, cluster that actually does the validation. There are two types of admission controllers we can have: validate, or this is going to be a mutate. And if all of your validations are passing, all of them, because you can have multiple, then your request is stored in the etcd database or HCD database, from where the pod controllers, they will be like, okay, there's a new resource in the HCD for which the spec does not match the status. So they reconcile the loop, and then they create you a pod, they create your secret, whatever they do, it is their responsibility. They're already being coded. We're going to talk about this bit. Okay. Another case is, let's say you want to stop people from using images from Docker Hub. We know that Docker Hub is a public repository. Anybody can just go ahead and put images. We don't know if they are scanned or not. God knows for how many years there have been images that have not been updated. So why you would not allow them in your dev environment? You can have a bit relaxed developer environment where you say, okay, some images are allowed, but you would definitely not use some of them in your production environments. Even if you want to use those Docker images, you would take the image from Docker, you would mirror it in your repository, you will scan it, you will see this is free of any vulnerabilities, does it have any active CVEs? If not, then you allow that to production. But never in production you would want to use latest Docker images. Some people do that. It's an opinionated, it's an opinionated thing, but you get the idea. And this is going to be our, this is something you can also control with Kyverno as a policy engine. You can say Kyverno, in this namespace, no images from Docker Hub. It is simple. It's a YAML, but we want to go beyond that. How does it really do the validation? So we will be building our own tool that stops you from using some Docker Hub images in some namespaces. In certain ones, it will allow that. In certain other ones, it will say you can't use images from Docker Hub. That is what we're going to be building. So how does it work? When your request is sent to RBAC, and then when it goes to the admission controller, the admission controller forwards it before it sends it to HCD. The admission controller sends it to a piece of software. It sends a couple of things. The first thing it sends, I can increase the font, is something called an object in Kubernetes, which is admission review. So it sends the entire spec of your object to this piece of software, and then this software does whatever it needs to do with this object that is being sent. It does a validation on that. For example, if I'm creating a pod, how the pod YAML is. If I'm creating a pod with a YAML, that whole pod YAML is being sent in this admission review. If I was creating a deployment, it would send the deployment object. If I was creating a secret, it would send the secret object. So the software can access what the user is trying to actually create. And based on this, it sends a certain response, which is expected by the admission controller. And it also sends an allowed field or not. So is it allowed in the end true, or is it allowed in the end false? And based on this, your request is going to be stopped or allowed to go in the HCD cluster. So this is what we will be building. Now, when I say that the admission controller will be making an API call, that tells you you need a web server. You need a web application where you can host this software that the admission controller can forward this object to your API. This is where you will be hosting your API. And as I said, we will be building this in Go. There are many different ways in which you can have an API server built in Golang. Again, this is not limited to Golang. The reason why I choose to have Golang is because I'm also working on that, and it's a bit easier for me than other languages. But you can do this in Python. You can do this in even Bash would work. But it depends upon you what language you're comfortable with, right? That's where you would be learning. So you need an API where you would host this validation logic. And for that, you need a web server, because APIs need a web server. That is what you will be using. So we will be using a web server on top of which we will be hosting our API that would be queried by the admission controller and then do the validation magic and send the result back. Okay. So there are, as I said, there are many ways of building an HTTP API in Golang, where you can say if you hit slash, you get hello. If you get slash hello world, you get some responses back. Like in Python, you have Fast API, you have Django as a framework, right? You don't have to write things from scratch. There's also a framework for Go, which is called the Gen framework. And this is quite popular. It is a very small and very lightweight web server that you can spin up for having your HTTP applications, and you can build your APIs and there. And this is a very simple one. For example, if I just go by this code, you are importing this Gojen framework, and you are saying that if someone sends me a GET request on this endpoint, I'm going to return a JSON message that has two things. First, an HTTP code of status OK, which is a 200, and I will be returning a JSON message, which is message as Pong. So you get the response back. This is a very simple API that accepts HTTP GET and returns you back a 200, always a 200 because it doesn't do anything, and sends a message Pong. And it runs on whatever port and whatever interface you want to run this on. And it is a very simple framework to get started. This is what we would be using for our API. Yep. Kamal, you have a question?
Yeah. So as you talked about the web server, so basically I might be wrong over here. Just correct me. So we are kind of like doing external authentication if we are sending the request to the web server, right?
You're right. We are doing something external, but it is external validation. We're not authenticating it. We are validate because authentication has been done on Kubernetes. That is
Yeah, yeah, yeah.
that authentication part was for maybe your LDAP, maybe your
Yep.
OIDC servers to do. You're already a part of now Kubernetes. Kubernetes knows you that you are a validated user. We are doing a validation now. So that is
So
what we
there
would be
could
doing.
be a latency, like if we are hosting it on the third party side.
Mhm. Definitely. This is what we are doing today. We would be hosting it somewhere outside. And in one of the sessions that I plan, I think I send a message on WhatsApp, we would be then moving this in the cluster. So it's, on the same pod network. So there's
Hmm.
no latency at all with that. So that is what also is planned for us.
Thank you.
I like the questions that you're having. And I would really appreciate if others can also turn on their cameras. It feels really good when you can see people that you're interacting with. Kudos to Swapnil and Kamal for that. So we would be using Go Gen. You can also have your own native net HTTP packages. You know how to make some APIs in some languages, right? You should know that. Even a simple slash would do. Now, we also need a Go project. Let's start doing that now. Okay. So I can make a project here. This is where I'll be having my own project, and I can very simply let me just quickly show you that. I can have a main. Oh wait, let me go here. I can have a main.go, and that's it. Now, if I run this, let's go to our terminal. I think I need some go get go mod init. It's example.com and go mod tidy.
Shubham,
This is gonna fetch. Mhm.
can you just zoom a bit, like
Oh yes,
when
yeah.
you're
Yeah, I can. So this is what I did. I just said that these packages are there and just download the gin package for me so that I can start using it. I'll rather open this in a different terminal. That would make more sense. So here I am. Now I can do go run main.go and you will see what happens. It says that now I have a web server which is listening on port 8080, which I can just simply go and say curl localhost colon 8080 and on a request called ping, because if you see in my code, I have it called ping. This is the API endpoint on which I'm listening. And if I say ping, you see, I get a message called pong, and it says that there was a request for which I gave a 200. There was a GET request from this IP address, which is my local host, on slash ping. If I send a ping like that, you get a 404 because there is no endpoint for that ping. So it's a very simple web server on which you can host your APIs. You can create some APIs and you can get it done with it. Of course, you can have some more logic in here. Right now, we're just returning the message, and this is what we're going to build the logic. I don't want you guys to spend your time learning how to build APIs that function. Rather, I want you to think about the logic those APIs can have. So we would use something called a blueprint for Go projects. And there's a very good Go program, which is called Go Blueprint, that actually spins up a Go project for you. And it can work really, really well. For example, you can spin up a Go project using this Go blueprint with support to your database connections, with support to your what web framework do you want to use? Whether you want to use Fiber or fast HTTP, whether you want to use what databases you want to support. Maybe your Go application needs access to MySQL, Postgres, SQLite, Mongo, Redis. So this actually makes a blueprint for your project so that you don't have to spend so much time in setting the project, but rather the logic of that project. This is what you would be expected to. This is what you would want to spend your time in, because nobody likes to spend time in setting up the infrastructure. And that is what we are also going to be using. So I would actually stop this, remove everything, because we start from scratch here. And I would do Go blueprint. So here I'm creating a new project. Let me increase the font. So here I'm creating a new project with no driver for the databases because I'm not using any databases. The name of my project should be Policy Engine, or rather give this validate. And I'm giving this my web framework to use Gin, because there are many frameworks that you can select, and this is going to give you the Gin framework. That is what I want to use for my application. And I do that. And it also says, would you like me to even track your source code changes? Or you might have a repository somewhere else. Do you want to only state the changes, or also commit the changes, or just completely start without a Git repository? For me, I would start without a Git repository, but don't worry, I already have the code in my GitHub. I will share this link in the end. We would put somewhere in the WhatsApp group so you can start working on that. For me, I start without a repository, and yes, to confirm the choices, and it's preparing you the project. Again, this is something which you can do in Python. This is something you can do in Bash, whatever language you need, because this would be running a web server. This would be then hosting your API. Now you can see rather here, this makes more sense for me to show this. You see, it creates the entire project structure for you. It creates a README file for you to populate, of course, creates a make file, creates a Go mod, it creates a checksum of your modules that you're importing, and it gives you these two directories. The first directory is called cmd API main.go, and this is where it already has created a web server for you. Okay? It creates here. This is the main function, which is where we start in Golang. We always start our program with the main function. So we create a new web server and we do some graceful shutdowns with some Go routines. Essentially, what you are doing is you are serving this program on the port that you want, and it also handles the graceful shutdown. You know how you send a control C to your applications? They just sometimes abruptly end. You don't want that. So this framework, this Go blueprint, actually gives you a Go gin that can listen on control C, and then you can do your validation, or you can close your HTTP connections. You can update your counters if you want. It's a very production ready it's a very production ready blueprint that it gives you, and you can use that. Other thing that it gives you is it gives you a folder called internal, and here is where you have a server. This is where you actually you start the server here, but you define the server in this location. Okay, so you're defining a function called new server, which returns you an actual HTTP server, which is listening on this port number. We'll change that, and it just returns a web server to the application which is the main function. And the actual thing that's being done is here. You see, this is where you register all of your routes. The routes are your API endpoints here. I could say that if someone sends me a GET request on called Shubham, just send them. Let me make a new function, and I would say Shubham handler, and this would also be like Shubham handler, and this would be message, hello from Shubham. Essentially, what this does is you're doing two things in this function. First, you are defining your code that will be executed if someone comes on a certain endpoint with a certain HTTP GET or POST, the HTTP methods. Guys, if you have any questions, You have to let me know. Otherwise, I'm just going to skip on these things, and it would be a challenge to keep up. Okay, some level of programming is expected, not Go, but you have to understand what is an HTTP verb, what is an HTTP get, what happens if I hit facebook.com/home or facebook.com/login, some different code is executed. That is what we are doing here with our Go routines. Yes, with our Go gym. Yeah, Kumail, go ahead.
So when we are creating this kind of API, so why don't we can use API gateway in Kubernetes? That will be doing the same stuff, right?
No, actually not. So if you talk about the gateway API in Kubernetes, that lets you expose your applications which are running internally in Kubernetes. Think of this as an ingress, but
Yeah.
for your TCP connections, for your gRPC connections as well, because ingress only listens on HTTP or serves on HTTP. This thing is where you are saying, I have an application. Uh, API gateway will come after if you want to expose it to outside. And this is a good question. Maybe you have a Kubernetes cluster where you run your validation logic, and other clusters need to talk to that validation logic. That is why you would use a gateway API to expose it for the outside world. But at least to build your software, that is where you have to define your own logic in those APIs. That if someone comes to my application through the gateway API and says /validate, what to do. So gateway API is more on infrastructure level. This one is what to do once gateway API has sent your actual request to my app or my endpoint. What do I do then? So that's where it would be used. Um, and here you can see we have a Go test, which I'm not going to use. So I'll just delete this because we do the testing ourselves. For the server, I would just say that I would be listening on port 8080. This is not returning any error, and this is the port number, and this should be, it's a string, so I put this as a string. So you can customize these things with the environment file, of course. This is so flexible for you. I'm just keeping it bare minimum, so we know what's happening. And if I run this now, I go to validate, and here I can do go run cmd API main.go. In Golang, your function, your program always starts with main function, which is written here. You can see there. So this function is where you actually start. And then you start serving your code with other, from other directories. For example, here you can see you are calling all of your code from the validate internal server directory. So it's very modular. You only have main, which starts a function. That function is defined somewhere else, and you import this in main. You don't have to write everything in one single function. It makes it very, very modular. Okay, so that's going to be the case. Now I would just simply go ahead and start it. Now you see, it registers all of my endpoints that I have. This is the second part of the code where here I'm defining what to do in these functions. And in this, I'm defining what routes do I have exposed as an API. So I'm defining two routes here, which is going to be, this is the course config. We're not going to use that. This is probably where when you want to have only allowing certain front ends to talk to your backend, we are not using this one at the moment. However, this is the bit that we are interested in. I say that if someone sends a request of type get on my slash endpoint, I want to call a function which is hello world handler. And whatever happens in this function, then I want to respond accordingly or do my code in this function. The same thing happens here. If I do get on /Shubham, it's going to be like this. You might also have seen many APIs exposing a /health function, right? So seeing if this is giving you a 200 or not. That's exactly what they are doing. So they have something like like health function and is healthy, for instance, right? And then I need to define this function, what this is healthy function would do. Message would simply be, I am healthy. And it gives you a response of 200. And this would be is healthy or not. It's a Boolean. And if I stop this again and run it, you can see I now have the health endpoint, which says if you do a get request on health, I'm going to be calling a function which is defined in validate slash internal slash server. The function name is healthy. And that's what I'm going to be doing. So I hope this is clear how APIs are hosted, how APIs are built. If you have any questions, please let me know. Now, if I try to hit it, let's see. If I do 8080 ping, of course, I did not define a ping endpoint. So it's just going to say whatever. But if I do slash, you see, it says you gave a slash and I said message, hello world. If I do Shubham, it says hello from Shubham. If I say health, it says I'm healthy. Now, this is also, you see, when you do in Kubernetes, you remember you have those liveness probes and readiness probes in your application? Those probes talk to certain endpoints and they have to be exposed first. This is how you can build your applications with some exposed endpoints. If your readiness checks needs to talk to an HTTP server, which is in your app, give you a 200 between this time, maybe 1 second or 500 milliseconds or 2 minutes. God knows what your application is doing. This lets you be so flexible if you know how to build such things.
Just like health checks, right?
Yeah, exactly. So you could have a readiness check that once my application starts, maybe it talks to another server. And once it's ready, this ready endpoint says, okay, you talked to outside, you gave me what I needed, and now I'm up. So you check on your this health endpoint. If it's ready, then only start serving the request to this. But you at least need the application to expose something which your health check can then say, okay, I talked to the app, I talk on this endpoint, it was fine, it is ready. So this is how you can build your APIs when you are building applications from a developer point of view. We know how to use a health check, but what to be done in the application to say if it's healthy or not. That is what we are going to be covering today. So it's healthy is blah, blah, blah. I don't need these two because they don't make much of a difference in our lives. What we do is we need the Kubernetes logic here. We need to know if, when the API sends me a request, what happens. So let's have a new endpoint, which is called, if someone sends me a get request on validate, what to do. And I would say validate handler. Handler is something that uh, just do your that handles your request. So that's why they're called handlers. How many handlers you have? How many API endpoints do you have? It's the same thing. So I have a validate handler. The first thing we are interested to know is how Kubernetes takes your request and forwards it to the handler because you have to forward it. See, if I talk about this here, how would Kubernetes know that there is some API endpoint available at this location at mywebapp.com somewhere slash validate? Or even if it was in the cluster, how would it know about that? So for admission controllers, you can have these webhook configurations. And there are two types of webhook configurations that you can do. One is a mutating webhook configuration, and other one is a validating webhook configuration that tells you a couple of things. That tells you on what object do you want to work and what is being done with that object that you want to call the webhook. Maybe do you have any namespace selector that you only want to listen on? For example, if someone, if someone creates what? A pod where maybe any namespace, then you call this, this validate logic. Maybe if someone creates a secret, uh, again, I'd said create a secret, but a namespace called cube system. You want to then only call the validate logic, which is being hosted somewhere. And this validate logic has to be running on HTTPS because Kubernetes says if your validation logic or if your API is not running on HTTPS, don't even think about I would talk to it. That's like, I don't talk to people who don't speak secure, it simply says that. So you have to run your validation logic on HTTPS. You have to export it, and you define this configuration that if you have these checks, go to this location. And that is being done by two Kubernetes objects, which is going to be, if I say, is it visible, guys? Can you see the font?
Yes.
Okay. Let me do that. Where is it here? So I could say kubectl or get validation, uh, validating webhook configuration. This resource is defined in admission registration.kubernetes.io API. And if you do kubectl explain, you see, it is defined in the version 1 of the Kubernetes admission registration.io API. And this is something that can intercept your request and it can accept or reject the object without changing it. This is very important. It can accept or reject your object without changing it. That's interesting. So if you do on spec, so if I do explain validating Kubernetes dot configuration whatever dot spec. Oh wait, this was webhooks. Webhooks. And here's where you can say for how much time do you want to wait for a response? What rules do you have? Do you select any particular object? Do you select a particular namespace or not? Here you can see. And what we are interested in is the match policy or match conditions is where you can say uh, they all have to match multiple rules you can allow. But a very simplistic configuration would look something like this. So I can do Unity, if I already have built it, so it makes sense to get from there. Mutating webhooks, policy engines, validate, Kubernetes, validation. And I will copy this to community. I think it's code, validate here, copy. So this is our validating webhook. It says the name of my webhook, the name of my validating configuration is podpolicy.example.com. You can give any DNS compliant name. It has to be a DNS compliant name. And here is where you can define your rules that in this API group, if I want to use my pod, the pod is in the core API group. So you keep it empty for the core API. You define if there's a pod created in a certain, if it's created in a namespace, because pods are scoped to a namespace, I want to send it to this URL. This is where the client config is. So it's like I have a rule that if this matches, if there's a pod created in the namespace in this API version, I want you to send this to this location. And I want you to give me a response in 5 seconds. Of course, this is too much if you're running this coexisting in your Kubernetes cluster, but this gives you an idea. And again, you could see this is using ngrok or ngrok, on which I think Kumail has already given a session, right? So how do you expose your applications, which is running local, because I would be running this locally, but instead of setting a TLS config, instead of setting my keys, my certificates, I would just use ngrok to expose it to anyone so that you can also use it, and so can my Kubernetes cluster. So guys, it gives me a publicly reachable API endpoint, a URL, if you will, and that is on which I can use my application. So I don't think anybody has any questions so far. I'm not reading the chat.
Shubham, I have a question.
Mhm.
What happens if the webhook connectivity fails? Do we have a condition for that?
Yes. So that's a very good question. And this should tell you how a very simple problem like this can entirely stop you from creating your pods at all on Kubernetes. Because if you say, if you can't find this webhook, the request doesn't know if it has to be allowed or not. So you will stop everyone from creating a pod. This thing is so powerful that you can actually stop even your administrators from creating any pods or not, because the validation is like, the webhook is like, I don't know what to do. You ask me to go there, there's no one here. So it's just going to time out and stop saying the webhook is not reachable. So this thing gives you so much power that you have to be very careful, because you can just kill your clusters basically with this until you fix the webhook, or you delete this configuration so it doesn't go and check there. Now, I already have an ng-rock session running, which is probably, I don't have this. Oh, it's here. Yes, it's there. And if I use it, because it's listening on my port 8080 localhost, if I curl on this endpoint, which is, let's say, let me run it again. Now I have to validate. And if I do a curl on validate, you see, I get a response. It says I am healthy. So it's proxying my request over the internet to my computer here, which is where the application is running. So the first thing you would do is you would create this webhook configuration in your Kubernetes cluster. So let's do that. I would rather make a folder called Kubernetes and move my validating hook there. And I would do K-F Kubernetes validating webhook, and I would do create. Now, you see, this is interesting. I don't have my Go application. Do I have a Go application running right now? No, because if I do validate, it says there is no app. I haven't started it. And this is exactly the question, Swapnil, you was asking. If I have a webhook which talks to an application which is not responding, what is it that going to do, right? And that's what's going to happen. So I just created a webhook, which is this one. It says to talk to this endpoint, and the endpoint is not there because we don't have an application that is listening for requests on this API, because I didn't run my Go program. Now, if I do K run, that being said, I want to run an nginx pod maybe in the default namespace. You see, it says simply, you cannot create a pod. It says failed to call webhook. The server rejected our request for an unknown reason. We tried to go to the server, we didn't get a response back. So essentially, at this point, I've stopped everyone from creating any pod in my Kubernetes cluster, and I'm the cluster admin. So this kind of power is what you can get, which can make or break your Kubernetes cluster. So always try this thing in a edge environment or a stage environment before you move this to production. Because if you're trying this in prod, there are going to be people screaming at your heads, I can't create any pods. What's wrong with the cluster? So you have to be careful about this thing.
Shubham, just a question.
Mhm.
So to ensure availability of the webhook, can I create multiple instances of the policy as a on the web server? 2 or 3 instances of it, and if one fails, I mean the infra doesn't break and someone can create it to the
Absolutely, you can, because these webhooks are stateless. So you can have multiple copies of this webhook, which is again, you're going to have a load balancer, and let's say you host them in 3 EC2 instances, because they are just group programs. You create 3 EC2 instances, you have a load balancer, and this is the IP that you give to your webhook configuration. If one instance goes down, the others can still be responding, because the load balancer does know that this instance is now not there, I would forward it to others. It's possible. It is doable because they don't track the state of what happened with the previous requests. So you can do that. Okay, so however, you see, it says fail to call the webhook. But if I run my webhook, policy engines, this is not the directory which I was looking for here. It's code, validate, and here, go run main.co. Now you see, I have a validate endpoint. Now, if I try to do, I create a pod, I get a different response. It now says the server could not find the requested resource. Wait, it exists. So let me quickly check something. Internal server routes not go. Let's say it is validate me. So I know there's a different validation engine now. And I would go and edit my validating webhook, which is called policy, and it's going to be validate me. If I do a curl on validate me, I don't get a response back. Because I don't have my Go program running, of course. So if I do now a curl on validate me, I get the response back. That is good. So if I create a pod now, you see, it says I couldn't find the requested resource. That is different than the error we had before. Now you see, I get a validate me with a timeout of 5 seconds. This is something I want to show you that happens when you are creating your pod. See, on the left side, I get a 404 and there's a timeout of 5 seconds. This is what's being sent by Kubernetes. Because if I show you, miscellaneous community demo code validate here, you see, I set the timeout settings to 5, and this is what's being sent along with my validation request to my API server. If I do again, you see, any request that now I'm sending is being sent to my web application. That's what I needed. So you can keep doing that, and you can see on the logs that yes, your requests at least are going to your application. This is the first thing that we would be doing. Any questions so far? Doesn't look like it. So that's what we did. The first thing we are now able to do is send the responses to my API validation because I can see the logs that my application is being hit by something. But the API says, nah, it's wrong. It doesn't look right. So what you can do in Go, in the Gin framework, is you can actually read the body of the request that is being sent. And then you can work on that and respond accordingly. So if you want to read the body that is being sent with this request to your application, we can do something like this. So we go here, and I would say for this validate handler, if someone comes on the validate handler, I want to read the request body, and that's it. Wait, it's not the io.read all. I want to be reading this with the get raw data. Now, this function called get raw data for your context. So you have to understand something. Every request that is being sent to your application validation, GoGen attaches a context to that request. With that context, you can get the metadata about this request. You can get the payload that is being sent. You can get the time at which it was being set. And with this context, I'm saying that get me the raw data of that HTTP request that was being sent and store this in the body. Now I can say print the body, and here I'm simply printing what is being sent to me by my Kubernetes request. Again, as I said, guys, do not get hung up on what is this Go function doing, because it's not a class for Go. Rather, it is a class for writing your admission webhooks. I'm just telling you what this function is doing, and I'm doing it as best as I can, but we can't go into the details of Go. However, it's very simple. With this function, we get the request of the HTTP response that we are getting, and this function returns us two parameters, because you can see you can hover over and it returns me a string of bytes or byte slice and an error. And I stored this. This is a shorthand in Go. This is called a shorthand in Golang, where you can say that the first response is being stored in the body variable, and the second response, which is an error, this is the response it's sending. The second response is being set in a variable called error. And if error is not equal to nil, that means there was some problem that I could not get the raw data. And I would just simply say, return the response saying there was an error in reading that raw data. But if it was not, then I simply print the body of the request. I hope this makes much more sense now. Okay. So again, I have to stop my program and start it. You can use air being that can reload your applications while you make changes, so you don't have to stop and start this. But let's say I do this, and it says there's a 404 validate me. Wait. Now this is something that is interesting. You see, I said to my function that if someone sends you a get request, if someone sends you a get request, then run this handler. But in my logs, you can see here, I'm getting a post request. The validation webhooks always send a post request to your validation logic, to your validating APIs. So you have to change this, and you have to say, instead of using a get request, instead of using get verb, if someone sends a post HTTP verb here, then run this function. Okay, so now that's what I'm going to do, and restart again. And now let's see if I do krun nginx, and there you see, this is what you were looking for. This is something that's being sent by Kubernetes. This is where now things start to get so much interesting, because if I put this here, and if I ask it to format, where's the, oh no, chat, but maybe I can just do it here. So in this file, see, this is the request that is being sent by the Kubernetes server for you. This is where things start getting really interesting. So you see here, it sent a kind to your application, which is admission review. And this admission review always have a request. So every time you're making a request to your every time you make a request to Kubernetes, it gives that request a UID, and every time the UID is going to be unique. Whenever I say kubectl create me a pod, this request is tracked by Kubernetes, and it is given a UID to that. And there you can see the resources that are actually being created. The kind, the resource, the request group. What are you creating? You know, I'm creating a pod here, version 1. What is the name of the pod? You can see nginx. It gives you all this metadata. The namespace where you are creating this, it's called default. The operation you did was create. The user who did this is called system:admin, which is I am, because I'm using the kube config of my server. I am a part of these groups here. And this is the actual object that I'm sending, that I'm creating. This is something that we are familiar with. So I'm creating an object which is of kind pod, which has these metadata, that is what you love and remember. And interestingly, This is the spec of my container. If you check, I have some volumes, which is my service account token. This is what I'm sending. And I'm adding a config map as well, because you always have your root CA certificate in your containers in case you want to talk to your Kubernetes from a pod. And here you see a container is a list where I'm having one container, which is name nginx, and this is the image. The command that I'm doing is sleep infinity. Now, imagine this, guys. Once you have this sort of information, what can you not do with that? You can validate on this object in your Golang application, and you can then simply say, yes, allow this, or deny that. You can iterate over on this JSON that is being sent to you. And there you can say, maybe if the image starts with Docker Hub and the namespace is prod, stop, do not allow it, or just simply deny that. That's what you can do. And this is exactly what we would be doing now. Okay. So first thing, this is a raw object here. I can't read the object data without unmarshalling it. In JSON, you might have heard these words marshal and unmarshal. That is to store this raw object in a data structure where you can iterate on this, where you can access some fields of that data. And this is already a defined data structure. At least its structure is defined. And if you go to admission review uh, and dynamic admission control, this is where you can read everything about the Kubernetes admission control. It says that you can write your own admission server. The minimum thing, the webhook request that you get is this data, and they also expect some responses back. And if you look on the webhook request, um, this is what we got, right? We got a kind of admission review. We got a request where this is the randomly generated UID. It is a fully qualified group version kind for the object that is being modified if there's a sub resource. And then you also have the actual object defined here. It's a new object that is being admitted. So for us to unmarshal this raw object into a validating structure, we use the function called JSON unmarshal. Oh, where did I go? Wait a second. Just give me a sec. I'm just going to turn off my camera for a minute. I think there's someone coming over. Okay, right. So something is this anyone. So before we can unmarshal this, let me the camera again. See, before you can unmarshal this to a data structure, you have to tell your program that this is the format of my data structure. And then you can say, match this object into this data structure. And this actually already is defined by Kubernetes. So if you go to admission review, uh, go structure, and this is where you can find the admission controller package. Go already has types for everything. And so this is where it starts to get a little bit difficult because see, when you create a pod, Kubernetes needs to know what is the spec that you are sending so that it can validate for you. Sometimes, when you create a pod with a wrong YAML, it says this is not the right pod structure. So that is done because Kubernetes has created these specs for everything. They have a spec for pods, they have a pod spec for secrets, they have a spec for config maps, they have a spec for deployment, and this is where they know what fields are mutable, what fields are immutable, and this is defined in here. For example, this is the one where we are defining everything. So this is the API in which all of Kubernetes objects are defined. And you can see here, for example, if I want to see what is my spec for the pod, I would go to core v1 and wait for that to open. And here you can see everything that is defined in the core V1 API. And here you can see you have these types, and some of them would be even familiar. You know a config map, right? You know what is a config map, and this is the config map JSON. This is the config map structure which is being defined. In config map, you have a type, you then have the metadata, you have the data, and then you have the binary data. If you talk about not config map, but let's say you talk about a pod, because that's the least thing we all know. Let's go to pod here. You see, the pod is defined as a structure which is containing some metadata. It has some object metadata, the type metadata, which is kind and type, that's pod in V1. This is the object's own metadata, and that is the pod spec. And this is the status. If I go to pod spec, which is another data structure, and here you can define your volumes, you can define your init containers. This is exactly what your pod spec looks like. I'm going to send this to you so you can read this a bit more, because this would definitely need some more reading. But I think you would have gotten an idea that whenever you send a YAML or JSON to Kubernetes, it validates this request against a defined structure. And whatever object you're sending in whichever API version, they have it created a struct for that. They have a defined structure for it. So if I got an object for admission review, and if I want to use a data structure to store this data, it has to be a type of admission review. So we are creating a variable of type admission review in which I can unmarshal this data in that variable. Does that make sense somehow? This is completely new for us because as administrators, we never care about it. But it's just like you need a data structure that fits your data. It's that simple. You're making a circle, you need a circle. You're making a square, you need a square, right? So that's something. That's something like, I think you have a question.
Yeah. So who makes this validation? Is this a Kube API server that's gonna make this?
Yes, it is the Cube API server.
And also, I have one more question. How does the Kube API server knows to create a pod with the policy that's like you wrote a policy, right? And how does the Kube API server knows that this validates and now I need to create this? So
This is a very good question, Swapnil, and that happens because once you now know how to send the request to a validating engine. You now also get the request on the validating engine. You see the request that is being coming. The webhook that sent us this request, it accepts a response as well in a certain format. And that format is, for validating, it needs two things. First, the UID of that request, which is being sent by that, so same UID, and allowed Boolean, true or false. That is what it requests. It accepts, expects your validating engine. So if you go here, you see, I gave you the admission wait. Here, see the webhook response section for the data expected from webhook. So we send this thing, you see, at minimum, the response needs to be sending these two things. So you say, okay, I am now sending a response which is of type admission review. And the response is, for the UID you sent me, I'm allowing this request or not. Based on this one thing, it will say, okay, the pod was allowed, or maybe the pod was denied. So I think that should answer your question now, right?
Got it.
Which we will be sending, because right now we are just trying to intercept if we can read the pod raw data that was being sent. We have the raw data. We want to store it into a data structure that we can then iterate over. We can see the pod name, the pod images, how many containers it has, everything. And then we would say, okay, looks good. You can go ahead. All right. So this is where I have the raw body now. You can see we got the raw data, but I need to now unmarshal the body. And this is what I'm doing here with this function called JSON.unmarshal. However, this, we need to define what kind of data structure do you want to unmarshal this to. So this data, which is the body that is here, this body goes to a type of data structure, which is admission review. This is what we need to add to our program. You know, circle goes in circle, square goes in square. So we need to add a new type, and we do this in Golang using variable. And I would say, let's say we do admission review. It's over here. Admission review Go structure, and it is available here. Admission request. I think it's admission request. No, it's admission review here. So this is what I need to add into my program. And because Kubernetes has already defined this, the structure, this data structure, I don't need to write it myself. I can just import this. So I can simply say, there's an admission review type of struct. I want you to call that. And we can then import it here. And I can say admission v1 like this. Oh, wait, admission v1. And I think I'm using Cursor AI, so it makes it a lot easier to build once you have the logic, once you have, you know, the basic of what you need to do. We all use this is why I asked this question the other day in the group, that if you write something, if you make something, but you use AI, is it you who build it, or is it the AI who built that? And I think Guru was the one to answer this question, saying it's you who has the context, it is you who has the knowledge about it. It's just a tool that you are using. You would be Googling if it was not for AI. So we just use code completion in this modern era because we have to. So I am saying that whatever is defined in this, okay, which is available here, admission review, I have it as an alias called admission v1, and I'm defining now a variable of admission review. You see here? Now, this is what makes sense. I'm calling this API as an alias called admission v1, and I'm saying I'm declaring a variable which is name is admission review, and its type is something coming from admission review dot admission review. And this is the variable that we are calling. So this is how you call, or you declare a variable which is being defined somewhere else in Golang. Again, only in Golang. There are other ways of doing this in Python. I will say this again, do not get hooked on what is this happening in Golang. If you don't know Golang, this was not about Golang at all. This was about how do you build it. So essentially, someone else has defined a data structure, and you are just using that. If I wanted to use, let's say, if I wanted to use something else, maybe I say admission. Say if I wanted to use this type, it's here. This is the type. Maybe I want to use admission request. I would just say in my application, I have an admission request. This is the response, and this is the request. You see, these are the variables that are already defined. So I'm saying a variable, just like how would you define a name, which is a type of string. That's how you define it, right? You define a variable of type string. And I'm defining a variable admission review of type coming from here, which is imported. I think that should make sense to everyone. And now you see there's a red thingy because I have to download this first in my program so I can compile it, I can build it. I could say simple, let's go here because I do something else now. And I would say go get, I think dot, wait. Wait a second. Go get. So this is what you do. I needed to do go get and get me this API so that it's locally available now and I can use things from there. You see, now I get an overview that this variable is a struct which is defined by in the API admission v1, but we can call it now. And in this variable is where I can actually marshal this. So I would define it. Wait, I would actually define this in my function, not global here. Declared and not used, declared and not used. I know that, but let me just define this admission review. And this is where I'm going to be unmarshalling this. So I get the body, I get the raw data, okay? And it says, see, this is also something important. It says this function returns two things, body and the error. You are getting the error, but you never use that error. And I can simply say, if the error is not equal to nil, do this. So the warning goes away. Or I can also say, I know you are returning two responses for me. I only care about the body. I don't care about the error. So I just use an underscore that give me that, but don't really give me that. I'm not going to use it. You can also do that in Go. Okay. Now I'm just going to go and do an unmarshal of the JSON body. If we could not unmarshal, we would say could not unmarshal really. I could say error, there was an error, and we send a response back. Or maybe I can say could not unmarshal the body, and come on. Yes. So if error is not equal to nil, that means the object that was being sent by the request, you could not fit the square into square. You could not fit the object in the right data structure. It's just going to say cannot unmarshal. You might also have seen this error. If you send a integer in a field which is supposed to be a string in your pod manifest, it will say, I can't unmarshal this. That's exactly what's happening. You're sending maybe a different type of data structure in a field that expects a different object. So this is what unmarshalling is. Okay. So that's what we have done. Simply, we call a data structure that was defined somewhere else. We are getting an object type of admission review. We store that raw data in a data structure of type admission review. So it's a match for all the objects. And then I can say, now this admission review is, and I can say print the admission review. And this also has some objects, you see. I can now get the kind, I can get the request, I can get the response, I can even get the object here. It must be request.uid, request.kind, somewhere in a resources it should be. But I could say dot kind. And if I say type of resource that is being validated is a, and then I can say it's a request.kind. And then let me do that again. We start our program, go run, and I would say, okay, let's do that again. And you see, it says type of request that is being validated is a v1/kind is a pod, because that's what you are actually validating it against. And you can see this. I could have done kind, API version, request, or let's say name. Let's do the namespace in which this action was being performed, because we want namespaces. Kamal, I'll come to a question in a second. I would say object is being used in the namespace, and I would say review dot request dot, and here you can see namespace. I run that again, stop it, start it, and I do, here you see, object is being used in the namespace default. If I say any other object, okay, create namespace dev, and if I do now -n dev, you can see it says object is being used in namespace dev. So now we are building our logic. Now we are getting actually where we want it to be. We know the namespace where the request is coming from. If we could get the image that is being there, and then we can say if the namespace is dev and the image is from Docker Hub, good, allow that. But if the namespace is not dev and the image is from Docker Hub, stop it right there. See, this is what Kyverno does for you in the background. This is what an admission policy can do for you. Of course, we haven't sent a response back yet. We will do that, but you're getting the idea that we are building right now. Kumail, you had a question. Please go ahead.
Yeah. So when you run the program, we got a kind of like a whole big chunk of output, right?
Mhm.
So uh, what I am able to understand is that you are kind of like filtering out the kind of content from it, like what kind of content you need, like the namespace, the kind, and all, and then from
Exactly.
that you will be validating it, right?
Exactly. So I could simply say, we could even start doing it now because we have the namespace here. And let me make a list of namespaces which are allowing the images from Docker Hub. So we can create a new variable where we store this. So I could say allowed Docker Hub namespaces, and it's a string. You see, it's a list of string, and I'm saying that I allow it in dev or allow this in non-prod. This is a variable that I've created. Okay. And then I can say, I can have a simple loop or string dot contains, I think it's contains here. So this is a function that says if you have it here. This function contains gives me a boolean. It returns a boolean saying if your namespace is allowed in is in the list of these you know strings, or simply you could also say for here. So you get the name of the object. I'm just going to do this, and you see fmt.println, the object, we get the namespace of that object here, and I'm saying now loop over on all the allowed namespaces, and if the namespace that currently you are checking against matches the namespace that is being sent with the request, you will then say, uh, you know, um, you would through fmt.println namespace is allowed. That's it. Otherwise, you will just say it's not allowed. And if it is allowed, you could say allowed is true. And that is the logic that you will then be building. Does that make sense? Right?
Yeah. And one more question I have, just um joining to it, that you talked about Docker Hub. Let's say if I'm not pulling the images from Docker Hub, let's say
Mhm,
I have some kind of private registry and
mhm.
I'm pulling it from there. So will I be able to do that like efficiently?
So you can check two things. First, is the namespace that you want to work with, is it in your namespaces? Second, if the image is from Docker Hub, that is the one you want to track. If the image is from any other repository, you want to allow that simply because we only want to target if Docker Hub images are something we can set in our namespace. Everything else is also allowed. So you can do that too. So
So do we need to mention the the private registry URL in the code so that it would be checking over there, going to there and then checking that okay, if this image is there in the private container registry or not, and then coming back and validating it.
no, no, no. It will not. You will not need to do this. See, whenever you are sending a request, let me put it this way. Um, Image, let's say image is being called from, I would get the image something like this. It's not working right now. I'll tell you why. But then you would say, something pseudo logic would be if image starts with something like dockerhub.io or docker.io, because all the images from Docker Hub are from Docker Hub, then you would say no. So if it's starting from Docker Hub and your namespace is not a part of the allowed ones, you would say no. You don't have to go to the registry because that's the whole point. You just don't want to allow that. What would you achieve if you go to the registry? Nothing, right? It doesn't make any sense. So this is where you would build the logic of saying I don't care if it's this namespace and Docker Hub, that's a bad combination. If it's any other namespace and any other image, I'm not tracking those changes. They're default allowed. So this is what we go for, default allow. We whitelist everything. We only block on a certain namespace and connect these combinations. And this is what I would do. I would have a variable that is allowed by default. It's true. Everything is allowed. We will change this variable when it's a certain namespace, not dev or prod. And if the image is starting with Docker Hub. Does that make sense so far?
Yeah.
Okay, perfect. So we can then go ahead and let's do, if it's allowed, yes, it's true. It's a Boolean. And there I would say, see, we can get the namespace. We can also get the pod. Let's get the request UID. So println, you ask me to validate the request ID. And here it says I'm validating it. You ask me to do that. And I can say request UID. I did the request for the UID. And here, you see. So if you're interested in which IDE I'm using, this is Cursor from Cursor AI. I'm starting to use this a couple of days ago, and I think I'm quite liking it, to be honest. And of course, we will have to. So we see it's allowed now, but we haven't used it. So it's Go is like, yeah, here we go. This is now the Boolean. And now if I refresh, stop it and start that again. See, it says declared and not allowed. Go is very strictly typed. It says you have a variable defined, but you're not using it. So why define that? Why waste the memory for storing that variable somewhere? So I would have to say, here it says, you see, here, declared and not used. If I fix this in the chat, no, I can just say fm3 dot print is allowed true or false. So now that error will go away. Just Go shenanigans. Now I can say blah, blah, blah. I'm running this in the dev namespace. And you see, the namespace is allowed because you have a list of namespaces where dev is a namespace. And image is not from key.io, so I don't care about that. Simple. If I do, let's say, create namespace prod, if I do this now in prod, it says, as again, allowed. And that's a bug in our program. It says you're allowed in every namespace because we're not really checking if the request is in these namespaces or not. For us to do that, rather than using our for loop, we can actually use the strings package from Golang. And I can say, let's do allowed, and I would say, or not. And I could say, so this thing here is actually a Go shorthand. This is a Go shorthand where you are declaring and defining a variable at the same time. Rather, defining and declaring you get the idea. You do both of them at the same time. So I'm saying if I'm using the slices package from Go, so you can see package slices, it has a function called contains. That does this list or does this slice of string contains this namespace or not. And this is then going to say a Boolean. It sends me a Boolean called true or false. So then I can say, if it's not allowed, namespace is not allowed. And then I say, if allowed or is allowed, then namespace is allowed. Simple. You can also say else because it's a Boolean. Namespace is allowed there. So then we don't need is allowed right now. Namespace is allowed or namespace is not allowed. Start that again. Of course, same problem. I think is allowed. So I print here allowed or not. This is what I'm using. So Don't need that. Simple. If it's allowed or not, and we run it now again, and now you can see, I would say, if I'm using this in prod, it says namespace is not allowed. But if I do this in dev, it will say namespace is allowed. That's what we needed. Okay. Now here's Swapnil, what you were asking for. See, it says internal error occurred. Failed calling webhook, received invalid webhook response, because we are not sending any response that it accepts or understands. There's a certain format you have to send, and we are not sending that. We're not sending the UID. We're not sending the allowed or not. We are sending something it doesn't understand. So for two applications to talk to each other, they have to agree on a certain data structure or message structure. We send something it doesn't understand. So that is the problem. We'll come to that. Now you can see.
Uh,
Um,
Shubham, I had a question to the
Mhm.
flow. So you first, I mean, the YAML or JSON is first received, and then it checks the API version or kind, and then it unmarshals it, and then the admission controller will work right after.
Actually, it is something like this. So maybe I can draw the flow here because that's a good question. So first, uh, wait, my drawing pad just decided to sleep on me. Okay, it's waking up. Weird. The first thing that happens is we define the validating webhook config, where we define the URL. Okay, so the request that we have, I can probably draw a box around this. So we have a request, and then this request gets sent to the validating webhook. Okay, does that make sense? From there, we have a URL config, and from there, I'm sending this URL where my application is. In this application, the first thing that I have done, is unmarshal or get the raw data. Second, unmarshal it to a defined data structure. Again, if you read the word data structure, do not compare this or do not get confused with data structures and algorithms. It's just a predefined, it's a data structure. I can't say anything, but no algorithms right now. So with unmarshal this, the raw object, the raw data of API review or admission review to a defined data structure. And this is what's coming from this location here. And then the third thing we are now doing is we use the admission review variable. We use the admission review variable to iterate on for our logic. This is the flow that we have done so far. We haven't sent anything response-wise back. We will do that, but I think this makes sense of what has been the flow. Does that make sense?
Yeah. Thanks, Shubham.
Okay, no worries. So we use the admission review variable, and this is where we got to see the namespace. We got to see the name, the operation that we are doing. We are patching, updating, deleting, all sorts of things there. And now we need to get the image, because right now we are completely denying if you can create any container in these namespaces or not. We want to see if that namespace is in the list, and if the image that you are sending is that also, we need to see the image, if that's allowed or not. If it's starting with Docker Hub, then it's not allowed. If it's starting with anything else, it's allowed. So that is what we also need to do. Now you see, we were able to get this data, but now we are interested in the actual object that is being sent. And this object, I could maybe do request dot object dot spec dot containers 0 because it's a list, and then maybe get the image name. That's something I cannot do because this object also is a raw data. So just like we unmarshaled the admission review raw data into a variable, into a data structure that Kubernetes understands, I need to unmarshal this object key into a kind that it understands, and the kind is a pod. So we need to add this raw data, which is in the object contains the raw data. So I need to find a pod spec this time, just like we did this for the admission review. Now I will create a variable of type pod so that I have a pod data structure. I have a raw data that matches the pod data structure, and then I can unmarshal that. And if I do a V1 package, here you have the, the pod. Where's it? Where's it? There we go. Type pod. This is what I want to copy. So I copy this package and I go to my program, and now I say, please import this core V1 as well. And that's what I'm doing. I'm saying that I have see, this is how we name our APIs. I could have also said pod, and I could say pod.pod. But that doesn't make sense because this API has a lot more than pod. What if you want to use a config map? So you would use pod.config map. It doesn't make sense. So we create an alias based on the the API name and the version. So I'm defining a core v1 from this core v1. And then I can call anything which is defined in this API. I can probably call, see all these types on the left side, you see? I can call host IP, I can call my event, I can read my DNS policies, I can read my container status, I can read my config map, anything. Once you get to match the kind of data you are getting, and you can unmarshal it to the right definition because it's already been defined by Go for you, by Kubernetes for you. We just have to use it. That makes our life so easier. Otherwise, you will have to define this variable of the same type. Like if it's coming a pod, you have to get the metadata, spec, volume, containers, volume mounts, init container, everything you have to define. Someone has defined it, we just use it. So I would do the same thing. I will say that I am going to have a variable of type pod, and it's going to be of type core v1.pod. And you see, it automatically knows that a pod has a type, kind v1 with the object metadata and spec and status. It knows pod is a collection of containers that run on a host, which is absolutely true. And so this is the object metadata. So you have a kind, you have an API version v1. This is through the type metadata, the object type that you're creating, and the object's own metadata is its name, UID, blah, blah, blah. And these are the functions that you can do on a pod. Maybe you want to read the annotations of a pod. There's a function called get annotation. Maybe you want to read the creation timestamp. You might want to see, you might want to kill all the pods which have been created 20 days ago. So how would you do that? You get all the pods, you use these data structures which have the functions inbuilt, you get the creation timestamp, you convert it from today. If it's in the past for 20 days, then you delete it or you don't. There are so many things you can do if you know, these functions that are automatically available. Maybe you can get the labels on those pods. This is what Kyverno does for you. It uses the object that you send, it unmarshals it, it writes it into the data structure, and uses these functions. So I have a pod object, which is a core v1. Okay. And this is what I would do. I would unmarshal my object raw data into a pod. So I could say unmarshal the body, and here admission review. And here I would say unmarshal the pod object. And this is what I'm doing. You see, I'm saying same thing that I did before, exactly the same thing. I'm unmarshalling now a new object. So this is the admission review dot request dot object. If you go here, you can see admission review dot request dot object. This all raw data. This is a raw data, which is not defined in any data structure because the whole thing is a raw data. I'm now unmarshalling this into a variable of type pod object, which is a type core v1. And I know it's a pod. That is why I can unmarshal this. I can store this in a pod type of data structure. Does that make sense, guys? I think this is something what we did before for the whole object. Now we are taking the whole request we did it for because it was admission review. Now we are using the object which is being sent to us. If I was sending a config map, you would use a config map data structure. If I was sending a secret, you would use a secret data structure. Again, I want to emphasize on this. This has nothing to do with Go. You have SDKs for Python also. Whatever language fits your requirement. This was only to show you the internals. It is completely language agnostic. Of course, I'm using Go, so I'm using Go packages, but there are CDKs and types defined for Python also. I think they do. Otherwise, that would be really shitty. So that should give you an idea. Okay. And now once I have the pod object here, we can try to read the pod name. We can try to read the pod image. And then I can say, wait, I will just allowed namespaces, and then I read the pod marshal, and then I can say, here's the pod object. I'm just printing the pod object. Okay. Now let's read that again. Go run. And then I can say, you see, this now gives me here. That is my pod object. It says the pod object is, I've got a kind and v1, got a name, namespace, UID, I'm printing everything. But we could go it like this. We could say, just give me the metadata dot name. I could say, because I know the data structure now, I can iterate over on any key. And I could probably say, instead of printing the whole pod object, pod name space is pod object dot namespace. And if I do that again, refresh, because here you can see the whole object, and then it gives you the namespace. Pod namespace is dev. I get that one. And I can also say, what else do we have in a pod? Let's see. We have things like containers. Let's print all the containers. And this is a list. So we can loop over on all the containers of a pod. And you can say, see, because a pod can have multiple containers, you can read over on all the containers because each container creates from an image. And you can say, if in any pod, any container is from Docker Hub, you say, not allowed. We only have one. So I can use the, I can access this on the 0th index because array starts on 0. But if you have like 10 containers in a pod, you want to validate on all the 10. So you can loop over on this list of containers, see if the image is starting with this, and then break right there if you find it and say denied. Any questions so far, guys? I know we have passed the time, but I didn't imagine it would take this long, but we are almost finishing now. Any questions so far? Okay.
So, Shubham, this is a bit overwhelming, but with Kubernetes, it would be much easier, right? To unmarshal, and that's what it's going to do, right?
That's definitely a lot easier. That's why we use the tools. See, the reason why I wanted this is to stop your thinking from a point of view that I have used tools to I have built tools. Because what if I give you an example that Swapnil, we have this premium customer, they should be allowed to create 20 different virtual machines on our platform in the last day. But this one is only paying us $100, 100 euros. So this one should only be allowed in the one day, in the last 24 hours, only 2. Kyverno doesn't do that because Kyverno is stateless. It doesn't remember the past. If you knew this thing, because you know the username, because you see the users there, you could store this data whenever you create a VM, go to Prometheus for this user. And then you could use a rate filter from Prometheus. You can go to Prometheus and say, give me the rate of this user's creating VMs. And if it is more than 5 or more than 2, whatever, then you can say, okay, no, sir. In last 24 hours, you have crossed your quota. Or maybe you have a product which needs to verify its license first. So you can have the license in a secret and you can give it to your pod. When the pod is created, your validating webhook takes that license, does the login using OAuth because Kyverno doesn't support OAuth, validates the license, gets if it's validated, and then creates a pod. Otherwise, it stops it. So the whole reason why I want you guys to be here is to stop thinking there's a tool that does it. Rather, how can we build something that that tool doesn't probably have, right? So yeah, that was the whole idea that I wanted to do this. And of course, it's much easier to use the managed tools if they are there. Otherwise, we will be just reinventing the wheel. But sometimes we need to know how to reinvent so we can invent something better. That was my thing.
Makes sense.
So now because I have the pod object, I can iterate on all the namespaces and let's say loop over containers. And that's it. Use the AI. I mean, once you have the knowledge of what you are doing, it doesn't make any difference. I would have just gone to Google for loop, copy, paste my variables there, but because AI is there, we should use it. So see, you are looping over on pod object.spec because this is where you define your containers, right? Spec.containers. And now I'm saying container name is and container image is. This range function here, it does two things. It returns me the actual data and returns me the index. And because I don't want to use the index, I'm just using an underscore. This is a Go shenanigan. And I could say, let's run this again. And we run it. And here you can see what's going on here. You see, the pod name is dev. The container name is Nginx. And you see the image here. It says the image that you are using is coming from key.io. If I was using something from Docker Hub, I could say docker.io nginx latest or just nginx. It says now the container image is docker.io. It could be anything really, a random. So I can say random non-existing. And you see, random non-existing. So now we know the image. I'm going to keep it simple. I'm just having one container. But if you had multiple, this is exactly what you would do. You would loop over, and then you would say, if image equals to docker.io or image starts with docker.io, you will say stop. Because you only need to find one container that starts with Docker Hub to deny, right? If it's coming from Docker Hub. And I would say the image that I have like this. I don't need to loop over on things because I know there's only one element in my pod and I can access this with 0, but you would do a for loop if you want to iterate over on the list of containers. And now I can do my logic. I have the pod namespace and I also have the pod image. You see, now we have both of these things to actually make our logic. And then I can say, here, let me do it like this. Once we have both of these things, I can simply say, here, first, are you allowed or not? In allowed namespaces, if it's in allowed namespaces or not, okay? This is going to give us a true or false. And I can say, is image from here, is image from Docker Hub. And I'm using it hard-coded. But of course, when you would be building this, you can use a config map where you can give a list of configurations, add this to your container as an environment, and the application reads that environment and then does the validation. I'm just keeping it hard-coded to keep it simple. Okay. So what you have done is if it's from the allowed namespaces and if it's allowed from Docker Hub or not. So you could say namespace is not allowed, or Docker Hub. Now we need to have the logic. So block if image is from Docker Hub and namespace is not allowed, and that's it. This is your logic. This thing. If it's not in the allowed namespaces and you try to create an image from Docker Hub, I would simply say request status would be denied, or I would say just false. And I define this request status variable somewhere around here. Request status is, by default, we keep it true for everything. But if this is the case, if you are looking on my targeted namespaces and you try to use container images, then I would say, boss, that's wrong. You can't do that. So this is false. And then I can say print ln request status is true or request status is false. Does that make sense so far? Okay, now we have the validation logic. Any questions, guys? Okay, good. So let's run that again. And now you will see, wait, I'll just clean it up a little bit. We don't need the whole body. So wherever we have the println, I'm just gonna remove them. I don't need the whole object. I don't need the UID because we have it. I just need the pod namespace and the pod image. And based on my logic, I would simply say request, because otherwise it doesn't make any sense to print so much because it's hard to read it. Now, if I do this in the dev namespace and the image is random existing, it should be fine because we only care about images from Docker Hub. If it's in the dev namespace and the image is docker.io/nginx, it should be fine because it's a dev namespace. However, the moment I do prod, it is saying it's false. You cannot have prod images. You cannot have Docker Hub images in prod. But can I have like yes prod registry? Yes, of course. You can do any registry, but not Docker Hub in your production environment. That is exactly the validation we were looking at. Okay, so once you have this knowledge, again, do not be limited to Go, free your mind from that. But once you have this knowledge that I got a response, I validate on this, and can I do some decisions? That's going to make your life so much easier. Now we just have to send the response to the API, to the admission controller, which is what Sapnil you said. And we would at least need to send this. This is what we would be sending, right? So this is what it expects us to have: admission review, and then I need to send a response. Now, instead of sending this data, I want to send the response. So send the response, and not like this. What we need to do is we need to send admission review. We will have another variable which is going to define our response. So admission response here, which is admission response, is another type of admission review. Let me show you. So we have this type of admission response. What this does is it has a UID. You see, this is the minimum that you need to send when you are validating. So we have the data, we have the UID, we have the allowed or not, then we send it in a data structure that is accepted by the validating webhook. So I would create an admission response of type struct, which is already defined. I'll just call it here, and I would then set the response. First thing, if it is blocked, then we can also have a response. So you can see you have two things here. The total is false, and there are two things: allowed and result. Here, allowed and the result. See, guys, I'll slow down. I think I have to slow down. We defined another variable of type admission response. It is a struct. It contains multiple different elements. And if I want to access the UID from this admission response, I would use admission response dot UID, dot allowed, dot result. This is how you access any property of a struct in Golang. Similar to how you do this in, I think, in C as well. They also have struct. So I'm saying that for the response, is it allowed or not? No, because I just said like that's wrong. Otherwise, see, by default, this is allowed. Wait. So I would say the default response that I'm giving, the default response would be, we'll come to that. Wait a second. And so for the admission response, it's not allowed. And this is the UID, and I'm also sending a result. So we need to send these things. First, is it allowed or not? Is it, what is the UID that you're sending? And you can also send a message to your people. You can say, guys, this was the result. Maybe you can say, cannot, images from Docker Hub in this namespace is not allowed. Okay, this is going to be our actual response. We are creating a response, and we are saying if it's allowed or not, what is the UID and the result. Okay, now we would send our response back. So I would say send the response. Wait a second, we need to send the response, but it has to be in a certain format like this. Mhm. It's a blocking namespace, and this is not allowed. The status is denied. And I would then say send JSON hello response. Wait, because I need to see the C dot JSON. This is the function that will send our response. Okay, so this is sending a HTTP OK if it was okay, and the actual response. But we have to generate this response because we don't have it in a certain format which is expected. This is the one that I was looking at. You see, we declared a variable before, but we are saying that we are now populating this variable. The values are, if it's allowed or not, that is the request status. The UID is what you actually send, and then you can send the optional message if you want. This is going to be the message that is going to be then shown to people. Rather, we don't need this here. We just want to see if it's allowed or not. And we can just, let's pause on the message. And that's it. This is our validation. You see what we did? We looked on the object. We start from the beginning. We get the object. We get the UID. Then we got the pod information, and we checked if these are in the right namespaces and if it's starting from Docker Hub. We got the final response here, and this is what is the actual response that is expected. We got the allowed, we got the UID, and I think we also need a type. Like this. We don't have a variable called type meta. I think I need to also call this one. Need to have a variable. Admission v1, like meta. Yep. This is the type response that we are creating. Just give me a second. Do I have a type meta? No. It's in the admission review. So we have a meta v1. Oh, I need to call the meta v1 API as well. Here. This is the meta v1 API. And from there, I can have the type. So you know how every application that we build, it has a kind and a v1, kind like pod and API version v1. That is the type meta. So what the object is of what type? And what is their metadata? It could be a pod, what API version they are defined in, yeah, the group version and the response. That's what we are defining right now for the responses here.
Yep.
So my response that I'm sending, here is of type. So this is the type meta. I think I need to fix this in the a quick fix. There we go. Let's just, I think let's just send it first and then we see what the problems are. Okay, now, and then again, and now if I do docker.io in dev, what do we get? So it's still an invalid response because this is not the format that we are sending. We are sending the response, that's for sure. Let me just copy that. So we are sending the allowed or UID, but we are not sending this thing. This also is expected. So I think type v1. This is what I need to send because that's what it's expecting from us. And then the actual allowed or the UUID. But what the error with this is unknown field type meta. Okay, so this is a variable that I have not defined yet. So I would do that here. Type meta. Wait. It's in the meta v1. There. And we don't have meta v1 because we didn't define it. Now there is. So it's all a problem of defining the right metadata types. I think that was our main issue here. Declared and not used is type meta. Just need to not the address, doesn't make any sense, but I defined my type meta and I'm sending the type meta as type meta. What's wrong with this? Unknown field instructors. Wait, in the admission response, do I not have a type meta? Admission response, that's the type. We have the UID and we have the, okay. Shit. I think I got that. We need to send an admission review under which we will send a response. That's probably what I was doing. Yeah, we need to send this thing. I also have it done before. Let me just quickly check. What did I do? Yeah, I created the response, but the actual API response was the admission review. And I got that wrong. My bad. So see, this is the actual response we are sending. Okay, the response only has allowed the UID, and probably we can also send a result, but we are not sending one right now. However, the actual API review is what we need to send. So we are now setting the admission review, and this is what we need to send. Basically, you see, we need to send an admission review. I was trying to send an admission response. This was something wrong. We get the response, but we have to send still this admission review. This is where the type meta is defined. That's why it was complaining that for the admission response, you see here, for the admission response, it doesn't have a type meta because it's a sub data structure, which was something that I was sending in a bigger one. I don't know how to say this, but let me try that here. So I was supposed to send this thing. So this would make a lot of sense. I was supposed to send this admission review, which in turn has a admission response. And I was trying to define the type meta here, which is wrong because this admission response is encapsulated in the admission review, where I define the type meta and then I define the admission response. This is the two things that we need to do. Okay, and that's what we are doing here. So I define my response, the UID, and if it's allowed or not. And then I define the actual API review response. Because if you see here in dynamic, example of a minimal response from a webhook, it needs a admission review, not an admission response uh, naked, right? The response has to be encoded or encapsulated in the review itself. So it gets a review, it gets an admission review, does things, it sends an admission review with the response. So that is something that should make sense because when you get it, you see, you get the same admission review and you get a request. What you send is still the admission review, but a response. So we generated the response already, but we had to send the actual admission review. Guys, does that make sense? I think this derailed a little bit, but I think it somehow started to make sense in the end. Yes, Kamal, you have a question?
Yeah, so I just wanted to ask like why we are using type meta, because we can just use UID or a name and then is allowed is true or false. Why we are using type meta specifically?
That's a very good question. And the reason why you are doing this is while these are only two fields that you can type yourself, um, it should come as a habit of using the data structures which are defined. Because if tomorrow you want to work with a pod, for example, right? Or a config map that has like metadata, data, Boolean data, only three fields. But your code is much more readable because this type meta is a standard across everyone. No one needs to go and read what the UID you have given because they all refer the same data structure. So the program is much more easier to read and it generates a habit of using and importing Go packages which have already been written for you. Does that make sense? Right? Otherwise, I could have actually created my own struct. I just copy the code that is upstream and I paste it. This would work just fine because that's the right data structure. But we just call it and we should just use it. This gives you a habit of actually reusing your code. Okay. So now if everything is fine, I can run that now and see if that works. Okay, that does it. Now, if I want to use Nginx images in dev, you see, the pod was created because now the response was what expected. Admission review and the request true or false. But if I do this in production, see it says this denied the request without explanation because we didn't send we did not send a result. We just said stop it. We don't care about giving you a result. So this is exactly what the plan was to build something today. We have a validation engine that creates or allows the creation of containers from Docker Hub in dev, but not in production. Now you can also send some results with it. You can also send some messages to let the people know what really went wrong. Because without explanation, you're like, what did I do wrong? You start checking your command, you start checking your arguments. That doesn't is not very nice to people. So we can then say, I can send a result now, which is again of type status. Meta, again defined in meta. You could also define the method yourself, but it makes sense to reuse the things. And then I would restart this process and I can say now in prod, and you see it's now giving you the output. It says, if I do that again in prod, image is from Docker Hub in this namespace is not allowed. Oh, okay. Images from Docker Hub and this name. Images, my English is bad. Images from Docker Hub in this namespace are not allowed. Oh my God, that's horrible. Stop it, start it, and now you get a different error. You see, different error. Images from Docker Hub in this namespace are not allowed. Images from Docker Hub in this namespace. So this is how you can version your API as well. You can have a validate me v1, validate me v2, because this could have been a breaking change. So people who are already using your APIs, this is why we have v1 data one, v1 alpha one, v1 stable. This is how you check your APIs. Okay, so this is something that you can actually do with the validation engine. I think this is where I stop because I took more than enough time, at least 45 minutes. This is I was not planning. You guys have to go for lunch, but yeah, this is what we had planned for us today for the validating thing. Now, in the next session that I'm planning, if it goes ahead, we will actually take the request and modify that, and then send it back the response along with the modification. So if somebody is using Docker Hub, I change it. I don't stop it. I change it to you are not allowed to use dockerhub.com, and it creates a pod with that registry just to mess up with people. Or I have a better use case for that. But yeah, this should give you an idea of what validating engines will do. So I think that is it for the session. If you have any questions, we have some time. I mean, I have all day, but you guys go for lunch or whatever. But let me know if you have any questions. Otherwise, we'll stop the recording and then we're done with, at least from my side, we're done with things.
Hey,
That's okay.
so first of all, I'm very grateful for this session. I mean, this was awesome.
Thanks. I'm really glad it helped.
Yeah, it was awesome. Just to understand, I have two questions. What happens if my node restarts? Does it lose the connectivity to the webhook, or does what is it called? Does my admission controller, uh, it like what happens if the node restarts? It's simple.
You mean one of your Kubernetes nodes restart, huh?
Yeah.
If it affects the admission webhook, no, because it is running outside right now of the cluster. Even if it was running inside, if you have multiple replicas of this admission controller, then you can withstand the failure because it will then be running on the Kubernetes nodes. But right now, nothing happens. Nothing, absolutely no difference at all. If one of your node goes down, then it comes back up because it's not, see, this validation, this admission, this validating configuration is actually managed by the API server.
So
Your
it's like
request, right, your request goes to the API server. It never goes to the node. So as long as if your API server is down, you have bigger problems, then I can't reach my validation webhook before you reach there. So if your worker node dies, no problem, because that's not where your pod will only be landing on the worker node, and the validation has been done much before on the API server itself. The API server sends it here. The admission controller config sends it here, validates it, then goes to the API server, then to etcd. If your worker node restarts, it has nothing to do with the validation engines.
of course. But if the master does the webhook connectivity, at least needs to be established, right?
No. So the thing is, it's not like you open a long living TCP stream to these webhooks. It's only when you do. It's like an event-driven thing. When a pod is created, when there's a request to create a pod, it goes to one of your masters. As long as the request is going to a master and that can reach the API endpoint of a validation, it's fine. That's why you have multiple masters, because all of them would be at least send, all of them are sending to the same endpoint. So it doesn't absolutely make any difference on the validation, as long as you have one master, because if you have no master, that's a bigger problem. Does that make any difference?
Yeah.
Okay, cool.
Thank you so much, Shubham. And I have one question. Let's say if there is a Kubernetes administrator who have got a request to create a new namespace. So will I need to create a new kind of policy for that namespace, or is there any kind of automation we can do on our side that whenever there is a new namespace, the policy should be on that, like kind of like a initiation time, like when we are creating a namespace, the policy should be attached.
I mean, you want to limit the policy to a certain namespace. Is that what you're saying?
Yeah, like if there is an like we have a particular namespace already made and we have a policy, but there is a new request coming that we need to create a new namespace to host some kind of application, but we also want the policy should be on that new namespace as well, because currently what I have saw in the policy, we are hard coding the namespaces like prod, dev, and etc. etc. So how can we? Is there any chance or is there any way so that we can automate, like whenever there is a new namespace, if I want my namespace to be inside this policy as well, so we can do that, or we will need to go inside and then hard code it and do it.
I mean, you don't have to do that. See, right now, um, this could be done very simple. So again, this is it's easier said than done. But if I was to do that, the way I would do this is say please just give me 1 second, okay? This needs to draw. So if I am creating oh God, let's say if I create a namespace, okay, I want this to be in the allowed for Docker. This is what you're saying, right? How do we do this dynamically?
Yeah.
Oh, this is so bad. Okay, so let's say you want you have a namespace which is made by the administrator and it has to be allowed in the list of namespaces for Docker Hub. In here, I would actually have code, or I would, if I want to automate this myself, I would code a policy that listens on create for namespaces. Okay, and then I would have certain labels on this namespace.
Hmm.
Then in the policy, what I would do is I would read the labels of this one, and then I would write the namespace if it has certain labels in a config map, which is then being read by the actual enforcing policy. Where we have hard coded it right now, I would rather use a config map. So it reads from the config map the name of the namespaces. Okay. So I read the label on this new namespace. I see that it has the label of allow Docker Hub true. I update the config map to add the name of this namespace. And this is the namespace which is being used by the enforcement policy. So this would you would write two policies in this case. And then I would restart the enforcing policy to use the updated config map. Does that make sense somehow? If you want to
Yeah, it
really
does. It
automate
does.
this. Yeah. So this is what you would actually do if you want to automate it.
Yeah, because most of the time we won't be going for this part. We will be automating it because and there would be certain criterias and certain situation where we need to create new namespaces for some application or some kind of workload. So if we are going for this policy or Kyverno, we also need to have some kind of policy automation, like a CI/CD system, so that it will be taking up the new namespaces as you mentioned over here, and then applying the policy, enforcing the policy on the namespaces, whether it's an allow or deny.
Yeah, I think for this one, you're kind of overkilling this because we are writing another policy. This workflow really works well with existing Kyverno policies. You can just say, if any namespace is this label, allow Docker Hub images, just with a simple YAML. It does this heavy lifting for you in the background. But yeah, I just wanted to show you how you can do this if you want to code it. But of course, you would use your Kyverno policies for that because it's
Yeah.
a pretty good product for these validations. So you don't need to juggle with the config map. You don't need to juggle with two different policies talking to the config map. You just label the namespace, and if this namespace has that label, then the images are logged from Docker Hub. It's fairly simple in Kubernetes, just with a simple YAML.
Thank you so much, Shubham. Thank you for this session, and thanks.
Oh, awesome. Let me see if I have any questions. Just a stupid question. Can we do it without the HTTP endpoint, like directly manipulating the Kubernetes API responses based on the conditions? Um, uh, you cannot do that, unfortunately, because Kubernetes API, the web configurations, they only talk to the API endpoints which are HTTPS. You can't, you can have your own so you can have your own certificates, your own CA, and you can make that CA trusted, and you can get a certificate and the key in your application. So Kubernetes also trusts that certificate. This is what we do in the third session to actually host it inside. We use Cert Manager for that, so that it gets an HTTPS endpoint. But unfortunately, you cannot do an HTTP endpoint because it's then going to give you an error. The server send HTTP to an HTTPS endpoint. That's going to be an issue. Yeah. Couple of more questions. So do let me know you guys are there. You know how to reach out, and I would take the leave now then. Thanks everyone for joining in. I hope this was helpful.
Thanks everybody. Have a great weekend. Bye.
Thank you guys. Cheers. Bye bye. Good one.